Hi everyone, it's the Gossip Guy, your trusted source for news and developments from the world powered by Hashgraph and the Hedera Hashgraph ecosystem. And to kick off 2019, and thanks to Hashgraph Ambassador Lior Goldenberg, we were able to get a hold and share video from the recent meetup in Tel Aviv, Israel that featured Trowbridge, President of Hedera Hashgraph. Now, what made this meetup particularly special is that it also coincided with the 10-year anniversary of the launch of the Bitcoin network. So to start off the presentation, Tom provides some coverage as it relates to the development of Bitcoin, user adoption, and also its use cases, before shifting over to Ethereum and eventually diving into Hashgraph. For the Hashgraph portion, you'll notice that the materials have been recently refreshed to reflect some of the updates as it relates to the development of the Hedera Hashgraph network. Also, be sure to pay close attention to some of the details, as we also get some indication on the timelines for the announcement of the first Hedera Hashgraph Council members, the expected costs for transaction fees on the network, a look at a case study as it relates to OpenPharma, and also there's a special guest appearance from a furry friend. Now I want to give shout outs to Lior Goldenberg for sharing this with all of us in the community. If you don't know, Lior is an ambassador in Tel Aviv, Israel, and is pretty active in promoting Hedera Hashgraph within the Israeli technology startup scene. He also has extensive background in business development for technology companies. Recently, Lior has shifted gears and is currently working within the security token space and is continuing to promote adoption of Hedera Hashgraph amongst enterprises. So thank you, Lior, for this. I think you're going to enjoy this video. Make sure to watch it to the end, and also if you find it to be helpful, be sure to leave a like. Let's dive in.
I think everyone here knows who we are. We're based on our consensus algorithm. We're fast, we're fair, we're secure. You've heard some of that. Where do we stand right now? I think mainnet launch, open access, will happen in March of this year. Importantly, the real update is that we have our community testing program, which is live now. You can go to go.hedera.com and you can go to the App Store or Android download wallet, and you go to go.hedera.com. You can actually experiment with micropayments, use the network, and earn up to 1,000 HBARs by just testing the network. So it's live and functional right now. And that is, I think, a big, we did an announcement in December 18th, and we did a slow rollout, and I think we're going to make a much bigger announcement soon about that, and we're getting thousands of users actually testing the network right now. So that's a big, big update. It obviously uses gossip protocol and virtual voting. Who's behind it? Dr. Goldenberg and Mans Harman. Yeah. So these two guys are behind it. I think what's relevant here is the experience that they both have. Mans Harman, 2 degrees in computer science. He led the Missile Defense War Game Simulator at the Missile Defense Agency, and he was course director for cybersecurity at the Air Force Academy, and he is the non-technical co-founder. The technical founder is Dr. Goldenberg, PhD in computer science at Carnegie Mellon, 2 years, 9 months. I think that's a record. With a computer science degree from Carnegie Mellon, over 100 published papers in math. So this team, they worked together for almost 25 years. They met working for the senior scientist for machine intelligence in the Air Force back in 1993. So they were doing effectively AI before certainly me, and I guess most people in this room had heard of AI. The next question is, how many people have heard of Hashgraph 2 years ago? Anybody here? We got one, Lior. Very fitting that he's our first ambassador here and he knows of it. Sense as to when this project started. How long ago? It actually started in 2012 when Lehman began working on it. So this has been under development for a long time. Completed the architecture in 15, white paper 16, first enterprise client 17. We call it sort of a 6-year overnight success. It's been a lot of work in progress. So let's talk about Bitcoin. This is the anniversary, the 10-year anniversary of the first Bitcoin transaction, the first mined Bitcoin block, and this, puts kind of interesting and topical what was put on that first block, which was that the Times headline of January 3rd, 2009. It's actually why people speculate. One of the reasons people speculate that the Satoshi is British, because it was a British newspaper headline. But I also think it's interesting given the sort of instability of the financial markets right now. We've got the Dow and the S&P sort of moving up and down quite lot of volatility. So I think that one of the reasons Bitcoin resonated was the financial crisis, and we're seeing a lot of market volatility now, which is sort of reminiscent of where we were a decade ago. But I thought we'd look at, first Bitcoin as a payment. Where do we stand with it as a payment mechanism? So in terms of Bitcoin wallets, there are roughly 20 million Bitcoin wallets. There are estimates of it, nothing's exact. Is that a lot? Is that a little? People could have multiple wallets. Sometimes every transaction creates a new wallet. That's probably nowhere near the number of users, a fraction of that in terms of number of users. People recommend 3 million, 6 million, somewhere around there. Relatively small number. How small a number is that? Let's see how small a number it is. That's how many PayPal users are. About 225 million PayPal users. Now, how many MasterCard users? Well, there's about 600 million MasterCard out there. How many Visa cards? Over 1 billion Visa cards. So I think that puts the Bitcoin user base in the appropriate context of globally accepted, used payment mechanism. It's minuscule. It's accepted by tens of thousands of people. The first transaction was that pizza transaction, which happened over a year and a half after Bitcoin launched. So now we've got 20 million users. It's gone like this. It's nothing compared to where real payment mechanisms are. So what about as a store of value? Can Bitcoin instead be a store of value? And I think the answer is yes, but let's compare it with the ultimate store of value, which is gold. Now, supplies, what's interesting is that they're both fixed supplies. The reserves are about the same. There's 4 million remaining Bitcoins. There's 50,000 tons estimated. It's about the same percentages. How long it takes to mine all those gold reserves to know they inflate, whatever, who cares? But it's just sort of interesting stats. Bitcoin's value is 1/100th of the value of the total gold that's been mined. Let's look at store of attribute between gold and Bitcoin. Are they scarce and durable? Yes. Both are scarce, both is a fixed supply, both are very durable. Interestingly, the reason why gold is a particularly good store of value is that it doesn't corrode. Every other metal can lose weight over time. Gold does not. That's one of the very unique properties of gold. But so that they certainly share. But they divisible. Gold, the smallest really transactable amount is an ounce. You could transact as fractions of an ounce, but it's hard physically to do that. Bitcoin, as we all know, infinitely divisible. Transportable. If you transport gold, it's hard to transport a lot of it. You don't want to carry it through airport security. You can do that quite easily with a thumb drive for Bitcoin. So Bitcoin wins on transportability. Ease of storage. Gold's expensive to store. You can store it, but you need security, you need vaults, you need everything else. It costs money. Bitcoin, you can put it in your drawer. Now, what about track record? That's where Bitcoin loses. Gold has a 3,000, 4,000 year track record. Bitcoin's track record, as we know, is a decade. So that is quite limited. But the question is, how important is a track record in store value? So shift asset classes here, and just do a thought experiment here, and look about what kind of track record is necessary for store value. So this is Van Gogh. In 1990, he sold a painting. There was a Van Gogh sold for 82 million. 30 years later, 81 million, another painting of his. What's relevant is that during his life, he created 900 paintings. He sold 2, and sold them one to his brother and one to a friend. Basically worthless. In the 1960s and 70s, he started to become recognized after he died in 1890. But in the 1920s, people started to recognize him as one of the great artists. And he now is one of the most highly valued artists. So from zero value initially, in less than 100 years, he's become not just valuable, but one of the top artists. This doesn't mean you need to have, a decade or 100 years in order to actually have a store value. I'm just going to show you don't need 3,000 years. And over time, I think what people come to accept as valuable, that time is compressing. This is just one example of how that's actually happened relatively recently. So then, if you become a store of value, or to become recognized, what does it take? It probably takes popular acceptance. What is popular acceptance? How do you calculate that? How do you measure it? I think media mentions is a relevant piece. Media mentions here really went up in August of 17 when Bitcoin cleared $4,000. Interestingly, not far off from where it is today. But what's also interesting to me is when it declined after the peak, it didn't decline all the way back down. It stayed up. It stayed in the public consciousness. And I think as long as Bitcoin stays in the media eye, it will help price action. It will every day just solidifies people's knowledge, acceptance, and understanding of what this asset class is and what Bitcoin is. And that is actually a self-perpetuating cycle. Where the more it's written about, the more people probably buy it, the more people hold it, and it continues to and then more people write about it, and it continues to self-perpetuate. So if you're thinking about Bitcoin as a store of value, the tech component is important. I think that is the last feature which is relevant when people think about store of value. If people stop talking about Bitcoin, if it falls out of the press entirely, that's when I get worried about it no longer being relevant. Because then no one new is coming to buy it, no one's learning more about it. So I actually think this is a very relevant statistic over the longer term. But this has all been phase one, right? This was Satoshi's gift to the world, to all of us. He wasn't the first to conceptualize a distributed, decentralized payment mechanism, but certainly the most successful. But he started this. Now, phase two came years later. Clearly, beyond the store of value, distributed ledgers with smart contracts. And this is Ethereum. Obviously, everyone here knows that very well. It launched in 2015. The crowd sale was in 14. And how does Ethereum compare? We've got 38 million Ethereum addresses, about 1 million active users at peak. A lot, probably it's a smaller number right now. That obviously overlaps a lot with Bitcoin users in terms of wallets. 2,400 dApps on it right now. Interestingly, of those dApps, not many are widely used. And we can talk about and speculate as to why more dApps are not widely used. I think we're one of the people that are part of that, part of the solution. But the main thing Ethereum did was it showed the ability for smart contracts and the use of blockchain beyond just a payment mechanism, beyond just a store of value. And it catalyzed enterprise interest. And so enterprise interest, Hyperledger, you may not realize this, it launched not long after Ethereum, December 15th, same year. Hyperledger now has 250 member organizations, big brands, We could debate whether this is technically a distributed ledger. Some would say no, we might be part of that camp, but broadly accepted, they market themselves as such, so let's give them the benefit of the doubt for the sake of this presentation. EEA launched in March of 17, so it took a little longer to do that. They have over 500 members, so this just shows the amount of enterprise interest in distributed ledgers, which I also think is important. Now, everyone here isn't building on it. Some just write a $25,000 check, put their name on it, and they're like, yes, we're now paying attention to blockchain, done. But many are actually looking at it in more detail. And what's, I think, also interesting, it's not just companies looking at it, but it's also countries. So we've gone from Satoshi talking about a currency that will be extra country and extra judicial to a whole long list of countries, some of dubious credibility like Venezuela, to some of high credibility like Japan or Sweden or Israel, even talking about a digital currency themselves. And so this, I think, is also really indicative of the interest level globally where we are 10 years after Satoshi created this white paper. We'll see if any, how many of these actually end up happening, and if they actually are distributed ledgers. Spend some time with Sweden and e-krona, and the implementation they have there is probably not what we would consider a real distributed ledger implementation from what they were thinking about, but some certainly will, and I think it's inevitable that we have a national digital currency at some point, and I think it's worth thinking about how that impacts stablecoins once you actually have a digitized currency. And I think that's an inevitability, but I can't give you a date on it. Also, in terms of interest level, in terms of enterprises, we all clearly know the decline in price that Bitcoin has had. But if you look at it, while it's declined, this slide's a little bit dated, we're over 80% at this point, but the enterprise interest just continued to steadily march on. And in October, you had Yale investing in a crypto fund. You had Gary Cohn, the former CEO of Goldman Sachs and Treasury Secretary, join the advisory board of a crypto distributed ledger project. New Fidelity announced a digital assets group with a couple hundred people that it might spin off. These are real companies making, and real individuals making significant commitments. This isn't slowing down. And so the Bitcoin price, which everyone focuses on, misses the bigger picture of the broad move into this space across the board and across enterprises. But what do you need to actually have an enterprise-grade solution? We think you need four things. You need to have speed, security, governance, and stability. And importantly, there is not one ledger out there that has all these four. Not one. And so let's talk about one, which is, I think, phase 3 of this. And phase 1 is Bitcoin, which is sort of a skewed view either as payments or really store of value, I would say. 2, which is smart contracts. I think Hedera Hashgraph is basically the next third iteration of distributed ledger. And so let's go into it in a little bit of detail. Some of this you'll know, some of it you won't. We're not blockchain, we're directly acyclic graph. I think people here probably know that. Blockchain is actually designed to be slow. If it's not slow, it doesn't work. At least, proof of work blockchain, which is the most commonly implemented form of it, most widely known. If it's not slow, it doesn't work. So people try to do side chains and child chains and kind of create all this infrastructure around it because they're like, gee, this is so good. I love the security attributes of it, but I want to be fast. Well, it doesn't go fast. And it's not supposed to be fast. Every time you attempt to add speed, you are making a security sacrifice. And that's not true for Hashgraph. Lean designed this from the ground up to be fast, to be secure, and it makes no trade-offs. If you want to, there is something called Trinity, which is something that that some people in the industry have spoken about, where there's this necessary trade-off between speed, security, and centralization. And we argue that actually exists for blockchain. It doesn't exist for a directed acyclic graph, the way Lehman designed it. So that is actually a false set of trade-offs that you don't have to make. So how does it work? And we heard a little bit of this, so I'll go through it pretty quickly, and I can go into more detail if you'd like. But the gossip protocol with virtual voting. So this doesn't look random, but imagine Dave gets a transaction, gossips it out quickly, and it goes from 1 to 2, 2 to 4, 4 to 8, and just spreads geometrically. Importantly, though, it's not 1 to 1 with the way it shows. It actually can be 4 to 10 gossips simultaneously. So think about this happening far faster, far quicker with high propagation. As you guys can guess, gossip is very hard to shut down, very hard to slow down. It also doesn't matter if 1, 2, 3 nodes go offline because people keep gossiping and these nodes are always syncing up. And so the next element is what are they syncing? It's the event with 2 pointers, and these 2 hashes at the bottom basically tell the last member of the gossip and the last event they learned about. And that's important because that means that every node can build a history of the transactions in the network. And this is the big leap that Lehman made. It's the hardest part to explain. And so I have this picture here which I hope can explain it. But if you look at this graphic, you've got these 4 nodes. B goes here to D, D goes to B, right? And so this gossip happens, and then it happens this way. Now, when this happens, the history is encapsulated here. This history is encapsulated. So what that means is that each of these nodes, A, B, C, D, each have a picture of this graph. They each can see all the transactions in the order in which they occurred. And what that means is that when a an event is seen by 2/3 of the network, it is fully distributed and is added to the graph. So what that effectively means is that each node knows what the others know because they can all see all the transactions in the network. So A knows what B, C, and D knows. D knows what A, B, and C know. So each node here can vote on its own without talking to the other nodes and add the transaction to the ledger. All happen at the same time. They all run the same voting algorithm, and they all know the same amount of data, and they see the same picture, so it's all added at the same time. That's what gets you, that's a virtual voting. Now, what's important about this, among other things, is security. And when you have each node coming to consensus independently, that allows a terrific resilience to attacks. You can take nodes offline, and it doesn't impact the actual effectiveness of the network to come to consensus. It's highly resilient to DDoS attacks, which is the biggest vulnerability to any other or most other supposedly fast systems out there that usually have leaders. And so a Hashgraph is characterized by something called ABFT, which is asynchronous Byzantine fault tolerant. What that effectively means is that each node comes to consensus on its own. That's the asynchronous part, ABFT. And why is that important? Right now, you read about hacks and security in distributed ledgers. You're thinking about wallets being stolen, coins being taken. That's a security people are talking about. This is a different layer of security. This is about the overall network security. Think about the capability of what this network should be able to generate over time. It should be the Visa network plus all the logistics companies you can think of, plus loyalty programs. Everything could ride on these distributed ledger networks. There is no tolerance for them to go down. The Visa network goes down, that is nationwide news, probably global news if the Visa network goes down for an hour or two. It impacts businesses, commerce dramatically. This layer will be more important than Visa, be more important than Visa plus MasterCard plus others combined. And there will be no tolerance for hacks or for downtime. So the layer, which is the most secure, we think will generate the most amount of business because enterprises will not have tolerance for even the remote risk of attacks. We want this to be an enterprise-grade system suitable for mission-critical applications, and the only way you do that is by having the highest level of security possible. This and that is what ABFT allows. How do we know it's ABFT? Well, Lehman proved it in math proof, and then we had that math proof also checked and proved by a system called which was done by Carl Perry using formal methods. We published that as well. So you won't find any other protocol out there that claims ABFT. Others will claim something else BFT. All that means is they made assumptions under which their system is secure. This makes no assumptions. So be very wary of other protocols that claim anything else related to BFT, and think about any other protocol, how it will survive if it's shut down for any period of time, because I don't think the real applications will tolerate that. So let's talk about the public ledger. And you talked about, this is how we've set it up is quite different than others. We've broken apart consensus and governance. And this is another leap for people to me, where we're building a governance model that's diversified with 39 trusted institutions across 18 industries, all geographies, and time, because people are only in it for 3 years, or 6 years at the max. And consensus at scale will have thousands of nodes, globally distributed, with capability for many, many shards. Importantly, this is a huge point which we don't talk about so much. With proof of work, there are increasing benefits to scale. That is why you see the concentration happen with mining for proof of work in both Bitcoin and Ethereum, and soon to be others, where every incremental CPU you add gives you additional mining capability and helps you win that, crack that puzzle that much faster. That's not the case with us. It's proof of stake. It is just based on coin balance, and at a max, you no longer get any more rewards, so you can probably create another node. Those are the nodes. Nodes are then assigned randomly to shards, so there's actually no benefit to no increasing benefit to scale. That is, I think, a very big equalizer in terms of how consensus works. Let's talk about governance quickly. This is how we like to think about it, which is global regions, sectors, companies, and time is the fourth dimension. So 39 companies, about 18 sectors, 10 global regions. We are at work building this now. We intend to announce the first members in February. And no one else, I think, has something. People will say, gee, aren't you just one company? Isn't that centralized? And we'll say, well, find me one other protocol out there where the biggest influence is 2.56%, which is 1/39. It certainly isn't a foundation where the biggest person has only a 2 or 3% vote. There's usually someone pulling all the strings of the foundation. It's certain, just because you call a foundation doesn't mean it's magically diversified. This is by charter diversified. And then in terms of consensus, phase 1 in the order of 10 to 20 nodes, phase 2, 39, phase 3, thousands of nodes across all sectors, open to anyone who meets minimum CPU and bandwidth requirements. So imagine this being highly distributed within a year or so of year 2 of our real open access in March. And so what are we playing for here? What are the stakes? And if you think about technology in particular, but most businesses tend towards consolidation. Usually you end up with 80% of the market controlled by a couple players, and then a huge number of players dominating the bottom 20%. You see this in telcos, you see this in internet service providers, you see this, you can see this across many, many sectors, but technology in particular. We think that will happen in the base layer area as well. It won't be one protocol that wins, but a couple will probably dominate. And then the next question is, okay, if a couple protocols are going to dominate, then is that relevant? Is it valuable? We think the lower you go in the stack, the more value there is. There's TCP/IP, which exists. We are one layer above that. So this layer, we think, should be the most valuable layer in the internet. And that is a very, I think it's sort of not always appreciated. And there will be only a couple players that ultimately control that. So we're at the very bottom of the stack. And so what does it take to be one of these winners? That's where we talk about these 4 things. First, key performance. I'm going to talk about speed in a little bit, so let's go there quickly. I think the one thing on speed, it's not just about you want speed, but you need speed so that if you're slow, you only have a couple transactions, one transaction every minute. You don't care for every second. You have a 100,000 network, but you don't want CryptoKitties to come on and then completely seize up the network and your application can't work. So I think in general, applications will move to the highest CPS networks just for service level certainty. Next one, security. We talked about ABFT. You want the highest level security, so these things are going to be attacked. Governance. You need good governance. We've talked about our governance model, so you understand that. You need governance, and then you need stability. We haven't talked about stability. We're patented. That has been controversial. One thing I didn't mention with Bitcoin is the number of forks it has had. I think people are quite aware of the number of forks, especially given the market volatility of Bitcoin in the past, gosh, it feels like a couple of months at this point, but I guess it's only been one. There have been 44 or 45 Bitcoin forks. That does not lead to stability. Enterprises are not going to want to build on layers back and forth. However, despite us being patented, we're going to release the code and everyone can see it, but we think that the lack of forking will actually drive enterprise adoption. And is one of the reasons enterprises haven't adopted this technology more broadly and why they've in fact gravitated to more private solutions so far. But happy to answer questions on that. Here's where we are, bottom of the stack. Importantly, no license required. Anyone can build and run an app. That is also a misconception that sometimes is out there, but I really want to mention that right here. First three services, cryptocurrency, smart contracts, and file storage. Those are ready to go, and you'll see them in March. These are just a list of a couple of companies. We've got about 115 building on our testnet more announcements of that going forward. But let's have some fun and talk about speed. Why? You know, it's a proxy for network capacity and also cost and also service level. But keep in mind, speed is a lie. And speed's a lie because it matters the number of computers you're using, the geographic distribution of those computers, and time to finality. But despite it being a lie, it's still fun to talk about. So let's talk about our friends Bitcoin. There we are. I'm not sure what the transaction cost for Bitcoin is right now, but it's sort of ballpark. It's been $60. It's been less. I mean, it's all over. Got Ethereum at 25 EPS, cheaper than Bitcoin. You have this so-called next generation inflationary. We can talk about the problems with that model, but and then we have Hedera. And importantly, this number, very cheap, 62, basically 6 million to a penny. Now that's not the cost. The cost, that's not the price. The price may be 1,000 to a penny. We don't know what the price is yet. We haven't set that. But it's basically cryptocurrency transaction for us takes about 100 bytes. So you tell us what 100 bytes costs in terms of bandwidth and CPU. It's small. So that's our rough back of the envelope math. What we end up charging, we'll see. But let's put it into math, because numbers are sometimes a little hard for people to grasp. This is about right. So if you put a snail at 0.3 miles an hour, Ethereum is about twice as fast, turtles, half a mile an hour. You know, people say, well, gee, the fastest doesn't always win. Beta, you know, didn't win over VHS. And I just asked how many people took a donkey here versus a plane, and the plane won over the horse and the donkey. And that's what we're talking about in terms of speed. I don't think there's much debate about that. I also was trying to find, if anyone here has questions of it, a technology that capability that wasn't taken advantage of. Because you don't need that speed. It's not important. You don't need that cheapness. You know, that's what people thought when those huge fiber cables were laid under the ocean. It's way excess capacity. We'll never need all that. You know, level 3 in the U.S. put extra empty pipes when they laid their first cables. Figured just in case they just string more cables across. And sure enough, that's getting used. So I'm not sure there's actually examples. If there are, and I'm very curious if anyone has them, of technologies where there was capacity for which use was not discovered and implemented rather quickly. So let's talk about a particular use case. What can you do with this level of speed, this level of cheapness, and particularly using some smart contracts? So let's look at OpenPharma. So what's the problem? And this is very particular to the US, but I'm sure it's relevant to Israel, where in the healthcare area you have a web of competing regulatory frameworks designed to protect the consumer. And they protect the consumer, it basically requires certain data to be shared with certain parties under certain conditions. And the requirements in the US are different even state by state. And so what that means is that it's very difficult to actually share data. And if you get it wrong, there are massive consequences for getting it wrong. Big fines, and potentially put you out of business. Fine. What does that mean? It means people end up sharing that data less, which means you have real health consequences because of this data not being shared. So how can Hashgraph or distributed ledgers help? Using smart contracts, you can actually demonstrate the data takes a compliant path, and that can be audited real time by anyone in the system using APIs. That allows data sharing without any consequence or mitigating consequence of regulatory breach in a way that hasn't before been possible. And when you can share data that either wasn't shared or is now shared, either wasn't shared or took months to share instantaneously, can affect real health outcomes. So let's, and you can do that by the way while remaining anonymous. So let's take a look at a quick video and see if it's played and it works with the sound happens. So that's a real application being built on us now, which I think gives you an example of the all kinds of people interested, different species interested in the space, or broadening our appeal. But the idea is we take systems that aren't designed to interoperate. You can now, using APIs, you can allow them to operate in a way that never before was possible. That has lots of implications. Now, as a unique to Hedera? Not necessarily, but you need speed, and you clearly go back to what you did, the capability of having a service that is either highly resistant to downtime and to hacks. If you're sharing medically sensitive data, or you are doing even supply chain, you don't want that to go down for an hour or a day or a week. It can't go down. So that then goes back to the security level as much as it does the speed and cost and performance. Also, the reaching finality in seconds also allows a real-time tracking. If you're reaching finality in 5 minutes, 10 minutes, it's not nearly as effective. This next slide just shows the complexity of the ecosystem here and all the different players that are engaged just in this generic drug network. And by the way, FDA sounds like one entity. It's not. Here we're showing it as two. It could be as many as 5 different and that's the FDA. And you've got different pharma, different organizations, different factories, etc. All of whom are sharing data related to generic drugs. This is just one application, the first application. So then I would ask, okay, this is great. Why don't we see 1,000 of these applications? Why are we just learning about this now? Why aren't there 10,000 applications built on this right now that we know about and we're reading about every day? So I think we look back at the birth and early days of the internet. So it's hard to imagine, but in '92 there were 10 websites. We've come a long way. Does anybody know how many websites there are today? Yes, please? There we go. There you go. Yep. You keep going. You guys are pretty close. At least you got the order of magnitude right. Keep going. Keep going. There you go. We're just about 2 billion. I mean, who knows exactly? But big picture, it's a big number. So that 10 doesn't look so important. What I think is particularly relevant though is this. So these dots represent the top 20 most visited websites. Now, this is the year in which these websites were launched. So on average, they launched in June of 2002. That was 11 years after the internet started. We know today we're 10 years after Satoshi, so it's the perfect time to talk about this. But importantly, Bitcoin is not designed for applications like Satoshi. It's not what it's designed for. So you probably should start this maybe around the Ethereum launch, maybe in 15. Maybe you started even around our launch, but we'll see. But why I think that it started here, I don't think there's anything really special about 2002, but if you look, what happened before? Broadband became really available a couple of years before. And so if you look at this, some big sites we know well, Amazon, eBay, started pre-broadband. They were able to generate terrific network scalability, which made them very hard to supplant. And they also took advantage of broadband in a terrific way. But most of these sites started post-broadband. And when you think about it, the uses that we use our phones for and our computers, most of that couldn't be done without broadband. Some could, but most isn't possible. That's why it's become the phenomenon it is the ability for us to use the amount of data we do right now. And so what we think we are is that broadband provider to the whole distributed ledger space. We are fast, we're fair, we're secure, and we think Hedera is what is going to help drive these applications like Satoshi forward and actually help bring this next generation, this third phase of distributed ledgers to be broadly available to everybody. So thank you, and happy to take any questions.